The last thing we're going to talk about with the nervous system are the senses, okay? There's 5 senses, and they are listed on the back of your nervous system notes on page 6 that are posted on Moodle. And then also, you can see examples of the sensory organs on the official color picture sheet, which is also on Moodle. And again, only the parts that are checked off are the parts that you need to know, all right? Okay, so now we're going to start with the proprioception as our first sense, which is for touch, temperature, pressure, and pain. Our second sense we'll talk about is olfaction, just the sense of smell. Gustation is third, which is just your sense of taste. Fourth is auditory. Hearing and balance go together. And then fifth sense is optical for sight. So now let's go over here, and this is our first sense, proprioception, okay, up there. And what's going to happen here is for all our senses, we always want to know what is the sense organ. What's the organ that's responsible for picking up the electrical activity and then taking it to the brain to interpret it so that you know something's happening in the body. And then the cranial nerve that controls that sense. And then where is it interpreted in the brain, and where do you store that information on that sense? So that the next time you touch something hot, then you know not to touch it again because you know the response that you got previously. All right, so for proprioception, again, touch, temperature, pain, and pressure sensors. The sensory organs are in the skin, okay? Meissner's and Pacinian corpuscles, which we studied when we did the integumentary system. Are there other corpuscles in the skin? Yes, there are, but these are the 2 major ones right here. And then the cranial nerve that's going to make these Meissner's and Pacinian corpuscles come from the trigeminal nerve, which is number 5. And then where does it go in the brain to get interpreted? The parietal lobe. And where is it stored? The parietal lobe also in the cerebrum, the mainframe, okay? So if we look at a picture real quick, just reviewing this, and it's also in your color picture sheet, here is a piece of skin real fast, the epidermis, the dermis, the hypodermis, all right? And then here are our sensory structures, Meissner's corpuscles and the Pacinian corpuscles. So these they look like little onions, sliced onions, and they're high up in the dermis right here, very high up. And so they're in that papillary layer, if you remember that. And so these are the Meissner's. And so when somebody puts pressure on your epidermis, then that pressure comes down and hits this nerve tissue, and then that's going to create electricity, and then the electricity is going to go out of the skin, and then it goes back up to your brain and says, oh, it's cold outside. I'm feeling cold air come through your epidermis. And then that cold air creates the electricity. That's the stimulus to create the electricity. And so then your parietal lobe stores that as cold, okay, cold air. All right, and then Pacinian corpuscles right here are the large onion-like structures, and they're also made out of cranial nerve number 5, the trigeminal. And so Pacinians are for heavy pressure and pain. And so if you put a lot of pressure on somebody, you're squeezing or scratching their skin or anything, pulling at their skin, then these nerves are going to create electricity, take it up here, and again, interpret and store it in the parietal lobe of your cerebrum. So that's how your pressure, temperature, and touch sensors work right here, all through electricity made on this trigeminal nerve that goes up to the parietal. Now we're going on to the second sense, which is olfaction. And there's a picture right here in the corner on the picture sheet of the nose. And so what's the information you need for your sense of smell right here? So this is the second sense, olfaction. What's the sensory organ involved in smelling? Of course, the nose. Cranial nerve number 1 is what's going to pick up the scents, okay? And then here's something different. The olfactory nerve has to run into the mammillary body, which is a structure, an organ in the middle part of the brain that's going to interpret what you smell. So when you run over a skunk, you immediately smell that smell, and then that information will go on up to your parietal lobe and store that information saying, oh, you just smelled a skunk, right? And so it interprets it. So the mammillary body tells you what you're smelling, but it doesn't store it. It's just an immediate response. So the olfactory nerve is not just like a straight long nerve. It's made a little bit differently. And so I drew it. Here's the cranial nerve number 1, olfactory nerve. And at the end of it, it sort of becomes a big flattened area. And they call this area the olfactory bulb, okay, the bulb. And then little dendrites, hair-like structures, you know what those are, of neurons. These come down and they're going to essentially pick up things in the air. So basically, olfactory bulb is just the end of the olfactory nerve. It's a flat thing that's going to sit on top of a bone-like structure. All right, so over here, here's a picture, my version of explaining it. So here's a bad nose right here, stratified squamous ET with hairs, so you can relate to that. This is the opening, and we'll learn what that's called next semester with the respiratory system. And then in the inside of the nose, you've got pseudostratified columnar ET cells with cilia that will move the air throughout the nose. And so here's the idea behind smelling. So first of all, you have to have air coming in. Okay, so here comes air. Okay, so here comes air, and let's call it skunk air. Okay, and so skunk air is coming in because you just ran over one. All right, and so you smell this inside your car, and here comes the air, and it's going to circulate in here. Okay, great. And then here comes the skunk air, and the skunk air is going to hit these little dendrites coming off the olfactory bulb sitting right here. Now the dendrites come through a little foramen, and if you remember when we did the skeletal system, there was something called the cribriform plate, and it had foramen on it. And so foramen means hole, and so this bulb sits right on top of here, and the little dendrites come through it and hang down way up in the inside of your nose. And so the air is going to hit this with the skunk oils, the skunk smell, and so that creates electricity. And so now you just created electricity by smelling that oil from the dead skunk. And so that electricity is going to go up the olfactory nerve, and the first place it goes is in the mammillary body, right here. Mammillary body, right here. And that's going to tell you, oh, you're smelling skunk, right? You just smelled skunk. And so then, once you got the electricity here, it's going to go up through the middle part of the brain and to the parietal lobe, and then it's going to store that information right up there. It just stores it. And so that's how your sense of smell works. And so it all starts with the nose coming through. The air is going to have particle matters on it, attached to it, and then that's going to hit these dendrites. That creates electricity. It goes up the little dendrites to the bulb, and then it zooms right on up to the mammillary body. It tells you what you're smelling, and then it goes up to the parietal lobe to get stored. The third sense is gustation, which is the sense of taste. So also on your sheet, there's a picture of a tongue, the surface of the tongue, and the pattern to the taste buds. All right, so what are the sensory organs involved in your sense of taste? They're called taste buds, which are on the surface of the tongue. Then what cranial nerves are involved in your sense of taste? There's 3, 5, 7, and 9, okay? And so cranial nerve 5 is trigeminal, cranial nerve 7, facial, and cranial nerve 9, glossopharyngeal. So glossal means tongue, pharyngeal means the throat area. All right, and then where is the information stored and interpreted? In the parietal lobe of the cerebrum, okay? All right, so I drew a picture of a tongue sideways right here, and an AMP2 in the digestive system where the tongue actually functions. It's going to be much more involved, But essentially, here is a side view of the tongue, and on the surface of the tongue we have epidermal papillae, just like in the skin, okay? And so here are these little epidermal papillae, and you can see them on the surface of your tongue, especially if you brush your tongue. And so that is healthy for the tongue also. But your taste buds are going to be up in these papillae, up in the epidermis and the high in the dermis. And so here are the 3 nerves that are going to come in here. And basically they make these little round projections right here. And those are called the taste buds, okay? So all of these are taste buds right here, made out of cranial nerves 5, 7, and 9. So I color-coded them. So this is how it will work. So if you eat something, say a piece of black licorice, say here's a piece of food, black licorice, because I have a black marker. All right, so then the black licorice is going to give off juices with your saliva. And so here comes the juices. And so the juices are going to diffuse down here into the skin, right into the epidermis. And in the epidermis, you're going to have these little bitty, right underneath the epidermis, and sometimes at the base of the epidermis, you're going to have these little taste buds, little dendrites, areas of dendrites, just waiting for this juice to come here, and then that creates the electricity. So as soon as the juice comes through the epidermis and hits these dendrites, then you've got electricity. And so now the electricity is going to go back up here to the parietal lobe, and your parietal lobe is going to tell you what taste that you're tasting, and it's going to store that information about the licorice right in here in your parietal lobe of the cerebrum. So that is how your sense of taste works. It's all based off of these dendrites called taste buds from the 3 nerves, just waiting for the juices to come down here and then come across and hit that dendrite. That creates electricity, sends it up and to the brain, and then it interprets it, tells you what you're eating and if you should keep eating it, and it stores it for the next time you eat a piece of licorice. You'll know it's black licorice versus cherry licorice. All right, and so also you can look at the surface of the tongue and you can actually test different areas of your tongue for different flavors, okay? Different flavors or different tastes. And so it's called the surface pattern. Can you really see it? No, you can't see it. You can see your papillae on the surface of the tongue, but you can't see taste buds because they're underneath in the dermis at the junction of the epidermis and dermis. So here is a typical pattern for how your taste buds sort of sort out on the surface. And so sweet is usually at the very tip of your tongue. Most of your taste buds for sweetness are right in the front, okay? Then salty goes down the sides of the tongue, like 2 bands on both sides. And then in the back, bitter, and then sour, way back. And then in the middle, they've also said there could be another form of taste, and they call it the spicy taste. Spicy, because there's a mixture of different taste buds in here and different nerves, 5, 7, and 9 in here, and that creates your sense of spicy. Some people cannot taste spicy things, and that has to do with where the nerve is, how low it is or how high it is, and they may not have enough nerves in this area to ever taste anything really spicy. And so that is a variable. But the basic taste that definitely everybody has is sweet, salty, bitter, and sour. And of course your sense of taste is also influenced by your age and your sex, because guys have more salty taste buds and girls, we have more sweet taste buds, ironically. And so anyway, why is that? I have no idea. But that's basically, it seems to be related to your sex hormones, testosterone and estrogen. But can they definitely say that? No. So anyway, that's one of the things that there's definitely a sex difference in terms of salt versus sweet, right? And that would be it. So that's your sense of taste.